In this video, we're going to look at the concept of surface area. Now, I'm sure most of you have come across this term before, and its name tells us exactly what we'll be doing. We'll be getting the area of all the surfaces. So, from question to question, the way the formulas you have to use will change, and it all depends on the shape of the surfaces. We know we'll be using formulas for area, but which ones we use we don't know until we look at our solid and determine what the faces actually look like. So many questions might direct you to think about the net of the solid, and the net is when we open the solid out flat. So surface area is sometimes easier to visualise as a net. This net doesn't match this solid here. This net would, if we folded it up and put it back together, that would make a nice little, probably a nice little cube. So you can see that if you took this shape and you folded the sides up, folded that up, folded this up, created a top, you would get that solid. If I was asked to get the surface area of this little cube, I know I would have 1, 2, 3, 4, 5, 6 surfaces. The nice thing about a cube, they are all the same size. 6 surfaces that are all identical. So we can take a bit of a shortcut when we work out the surface area of a cube. We can do 6 times the area of one surface. And I'll just finish that off for you. The surface on a cube is a square, and the area of a square is side squared. That is a really simple example. This one, however, that I'm going to demonstrate for you is not so simple. It has, if I was to open it out flat and create its net, we would have a rectangle for the base. We would have a rectangle on the side that makes the sloping side, another rectangle out here that slopes up, and the two ends are your triangles. However, we're introducing another concept in this example, and it says it's open. Please note that. You must read the words of the question very carefully. If it's open, then it doesn't have one of these. That's gone. Means there is no end. It's a little bit like when we talk in the next exercise about a cylinder. So a cylinder is like a glass that you might have a drink of water from, or a vase that you might put a flower in. It's open so that you can actually get the flower in it. Put some water in it. It has one open end. So it doesn't have all the regular surfaces of a cylinder. So this triangular prism is open also, so we won't have that triangular end. Okay, so to get its surface area, I can see I've got 3 rectangles. I can never be sure that they will be exactly the same size. So we don't assume they're all equal. So I'll say that the surface area is 1, 2, 3, and 4. I'm getting this area of 4 sides, 4 surfaces. This one is a rectangle, it'll be length times breadth. This one is another rectangle. It'll be length times breadth. And the third one is length times breadth. Unlike over here, I knew that they were all identical. Here, I don't know that these rectangles are identical. And I've got a triangle to get the area of. And we know it's half base times perpendicular height. Let's have a look at this particular triangular prism. Let's start with the easiest one, which is 2, which is the bottom. And it is a rectangle, which is, and I've got my 2 here, 6 by 10. Now, like I've been saying, we don't assume that the other 2 are 6 by 10. So let's take a look at them and see if we can see. Well, we can definitely see the length of this one is 10. But what do you notice? There is no measurement for, we know that this is 10. Oops. But we've got no measurement for this. We don't know what that and that are equal, but we don't know. That sits on the side of the triangle, but we don't know its length. And it's at this point we have to remember what we learned in the previous exercise about when there is no number given, use Pythagoras. Think Pythagoras. So I have to do some little quick revision of Pythagoras now. I've got this triangle. This entire side is 6. I know the height is 4. And I want this side. If I'm thinking Pythagoras, I know I need a right angle triangle. So I have a right angle triangle. I've just identified that this whole side is 6, so this smaller side, or half of it, in that triangle will be 3. I then look and realise I have a right angle triangle with sides 3, 4, and if I learnt my Pythagorean triad from last exercise, I will know automatically that the length of that side of the triangle is 5. We've said here that this side of the triangle matches, this side of the rectangle matches this side of the triangle, so this is a 5. So I'm doing 10 times 5 for the area of this rectangle. So I've done that one over here to the one that's sloping at the back. Its base will also be 10. It's a rectangle, 10 by, and we're not given any other information, so we know that this is a nice isosceles triangle, and the other side would be 5 as well. Moving on to the triangle, and actually I should have had times 2. No, sorry, no I don't, because it's open. I've only got one, sorry, my mistake. So now we're moving on to our area of our one and only triangle, half of, what's its base? What was this? We can see in the triangle that is 6. And its perpendicular height is this height here, which is 4. And adding those together, we get 172. Please note, this is back to area. We've been using area formulas. These are all area formulas. Our units are centimetres squared because we're giving a measure of area, the surface area. I'll stop the video there. You can get started on some of the questions from the exercise that you can see are referring to surface area.